Today's lesson is on the sources of energy, specifically being geothermal energy, wind energy, and biomass. So starting with geothermal energy, we're going to push pause on this picture here so we can go through and explain why certain countries have this ability and others don't. Okay? And really the main thing comes back to our plate tectonics from grade 7. And if you do not have the lava, you need the lava, you need magma, otherwise you cannot have geothermal energy. For geothermal energy, you must have the ability to build pipes underground and let your water heat up. And when that water heats up, it is going to boil into steam, which spins a turbine, which runs a generator, which creates electricity. Okay, so again, same theme as the other days when we were talking about nuclear, right? Boil water, make steam, steam expands, spins turbines. Okay, so technically we do have hot springs in Banff and I think Fairmont, but maybe because it's national parks, I don't know. But we don't use geothermal energy here. Maybe we could, but we don't. Okay, the one that I'm most familiar with is this little bitty country right there called Iceland. Okay, they have this super amazing blue lagoon that I want to go to. It's on my bucket list. And right behind it in the pictures, there's always this huge factory looking thing, which is their big geothermal power plant. Yeah, putting that in the notes would be a great idea. I have that open for you too. Okay, so what's geothermal energy from? Comes from the magma. Surf yes. And need to be able to pump water. Spins turbines. Steam expands. Equals generates electricity. There. Thanks for bringing that up. Okay, so United States gets some, Alaska. So yes, for red is absolutely, we have a lot of that. And orange a little bit, and then yellow not at all. Which might be partly due to it not being available, but it could also be because people just haven't developed it. Hello, welcome. One thing that's quite neat about this picture is right here on the Horn of Africa. That's a spot of major tectonic activity. That little piece of Africa is actually ripping itself off of the continent, and eventually the ocean will fill that in. So there's lots of earthquakes in that area, lots of tectonic activity. Okay, so lots more geothermal energy available when there's hot spots. Now, I'm thinking they just push the fill in all color in these countries because not all areas in those countries would have access to geothermal energy. Okay, here's the specific how much energy is produced by the different places. Okay, so it looks similar to our other chart. Ethiopia right here, like on the Horn of Africa, has a reasonable amount. So blue is middle, is a little bit, yellow is middle, and then red is a lot. Right, so again, Iceland is pretty high. Italy has quite a bit, right? Think Pompeii, the big volcanic eruption that had all the ash that entombed all the people. And then Philippines, lots of earthquakes there. Mount Pinatubo. Japan, always lots of tectonic activity, like the earthquake that caused the Fukushima nuclear disaster. Apparently New Zealand, I don't know that one. And a bit in the US here. Okay, so what is exactly happening here? Okay, this is basically a fancy diagram that's showing that you have your power plant somewhere near the magma chamber. So you pump your waters into the Earth's crust, okay, as deep as you can, closest to the magma chamber. You put your cold water in there, and then the hot water boils, turns to steam, steam expands, spins the turbine, spins generator or spins a turbine, which when we look at motors, we'll understand the generator part better, and we can ship the power lines, ship the electricity to the cities with power lines. Now, unfortunately, it's almost never where you can actually produce the electricity you need right in town. Okay, usually it's by the hydroelectric dam, or it's over by the magma chamber, or it's in a wind farm somewhere. So you always seem to need these power lines to get to your urban centers. Okay, then you're going to recycle the water because that's going to save money and time and effort. This picture I literally stole from your grade 7 Planet Earth page. Okay, and this is showing the ring of fire around the Pacific, Hawaii, okay, the Mid-Atlantic Ridge, where there's a lot of geothermal energy there, but I mean it's under the ocean, so nobody cares. Okay, and there's Iceland, and over here there's that Horn of Africa. Okay, so we would expect in these areas that geothermal energy would be accessible. Okay, next, let's let this video explain it to us with a little more detail.
Relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity.
Okay. So there's the factory and all the pipes that are needed.
Okay, here's how geothermal works. Heat from the Earth's crust warms water that is seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust or plates meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. Engineers have developed a few different ways to produce power from geothermal wells drilled into the ground. Have a look at this. It's a dry steam geothermal power plant, and it's the most common type of geothermal technology used today. Underground steam flows directly to a turbine to drive a generator that produces electricity.
Okay, so let's watch that bit again. What happened?
Today, underground steam flows directly to drive a generator that produces electricity.
Underground steam, turbine, electricity.
Flash steam power plant. A pump pushes hot fluid into a tank at the surface, where it cools. As it cools, the fluid flashes, or quickly turns into vapor. The vapor then drives a turbine and powers a generator. A binary cycle plant works differently. It uses two types of fluid. Hot fluid from underground heats a second fluid, called a heat transfer fluid, in a giant heat exchanger. The second fluid has a much lower boiling point than the first fluid, and so it flashes into vapor at a lower temperature. When the second fluid flashes, it spins a turbine that drives a generator.
Seeing a bit of a pattern here, spins a turbine, runs a generator, electricity goes through the power lines to town. Okay. And really, that's all there is to it for geothermal energy. Okay. When we move on to wind, again, we're just getting something to spin. In this case, we're letting water do or air do it. Okay, and I think I have a picture up here somewhere about tidal energy. Okay, so there's some Spanish and Tagalog translation there that we prepared a different year. Okay, I'm just backtracking. There's solar panels, the wind turbines, right? So this is in Calgary, Alberta, by Bow Valley. So I was camping and took a picture for you. These are wind turbines stuck in the ocean, right? It's usually pretty windy in the ocean. So if you build some wind turbines there, you're going to get some electricity. Here's the tidal energy one. So as the tides go in and out twice a day from the moon, okay, places like the Bay of Fundy should be using this. Okay, however, that's also a very rich in biological diversity zone, right? Things like coral reefs and shells and lobsters and all those delicious living creatures like to live there. So having all this energy production equipment in there and power lines tends to upset their habitat. So not great for the environment, but a bonus for us if we can get it to work because it's free once you build it. Okay, here's a different model where you're using the tides to spin the propellers. Okay, another different design. Okay, so this is a picture of the Bay of Fundy in Canada. We have some of the highest high tides and lowest low tides in the world. So that would be a great place for using that kind of energy. Can't do it here. We have no ocean, right? No ocean in Alberta. Yeah, so that was my bit about tidal energy. Okay, so with your wind energy, you're spinning these turbines, okay, and that powers the generator, and then your electricity goes down the pipe to the people. Okay, a lot of people, Trump included, say, oh, it kills birds. Don't like the idea of wind turbines because they say they look ugly. Okay, you're looking at this beautiful field and they don't like seeing these big machines in the middle of the field. I think they look kind of cool because it's like science. But for sure, okay, if you just wanted a beautiful landscape for your movies or whatever you're doing, and you can't do that. Okay, the other argument they make with wind energy is that this design takes so much energy, 260 tons of steel, okay, and they're never going to get back as much electricity and energy it took to make the wind power turbine as it did as they're ever going to get out of it, right? So it takes more energy to make it than they're ever going to produce. So that's a waste. And that's what a lot of people who say wind energy is stupid will tell you, okay, is that they're not very efficient. Okay, so the concerns are they're expensive, intermittent, intermittent is where it doesn't work all the time. Okay, so just like sunny, solar power, only works when it's sunny, okay, not when it's not sunny. And then people think they're ugly, okay? So we have different solutions, and those include different designs. So we can have kite power turbines that move like hummingbirds' wings, and bladeless turbines and tree leaves blowing in the wind. Okay, so I've found some videos here for you to check out if you like that can be powered by the wind, or in this case, you can even throw it in the water and it will spin and power your cell phone, so that'd be great for hiking. Okay, so the one I grabbed was this one that I'm going to mute just because I want you to see the different design. So I'm pretty sure we could make those way prettier. We put you fine art students, put a pattern on them, make it spin with optical illusions maybe, okay, and those take way less wind to spin. Okay, so if we can use different technologies, we could put those in town. We don't need power lines to go super far away. Okay, and there's no reason they have to be that ugly, right? So good job. They're making a step towards the future in terms of trying to make it look cool, but I guarantee people could do a better job, make it look even better. Okay, so we watched most of that one. Okay, and here's your wind energy turbine video. Play.
The answer is much simpler than you might guess. It starts when the wind blows and slowly turns the turbine's blades. In the main housing, called the nacelle, there's a lot of components for stability and direction, but the key components of a common configuration of wind turbine are the drive shaft, the gearbox, and the generator. The force of the wind turns the blades, which turn the drive shaft. The drive shaft has a large gear in the gearbox that turns a smaller one. Because the second gear is smaller, it turns faster, fast enough to make
Okay, so it spins. And this is gears like you learned about in grade 8. Okay, so because your big gear is turning the little gear, right? Your driving gear is spinning your driven gear. That's a multiplying gear. And you're going to get a lot more spins for every spin of the rotors. You're going to get more electricity being generated. Okay, and then here's the power lines going to the different houses. And that, I think, is all I wanted to say about wind energy, which is good because I'm just about my 15 minutes limit. Yeah.